Hi, my name is Ryan Kelly and I am a student at Monash University in the Department of Electrical and Computer Systems Engineering. Also, for the past year, I have been an engineering intern at the company Bega Cheese. Working for Bega Cheese, I have been working out of the Vegemite Whey factory in Port Melbourne. I have been tasked with the feasibility of a solar project. This solar project aims to utilise the vast roof space at the Vegemite Whey site and promote corporate social responsibility for Bega Cheese. The amount of roof space available at Vegemite Whey has been calculated as approximately 16,000 metres squared. This would allow for a 2,225 kilowatt solar system to be installed. By applying an industry standard model, this system would produce 2.7 gigawatt hours of electricity in its first year. By applying a financial analysis to this industry standard model, we can see that the system will have an internal rate of return of 12%, a net present value of $16 million over 20 years, and a 6-year payback period. During my time at Bega Cheese, I have developed a new solar model using MATLAB software. This solar model predicts that in the first year of operation, the system would produce 2.9 gigawatt hours of electricity. By applying the same financial methods as the industry standard model, we see that this model has an internal rate of return of 14%, a net present value of $20 million over 20 years, and a payback period of 5.5 years. Let's put money aside for a moment. The system also has other benefits which will promote corporate social responsibility for Bega Cheese. Some of these benefits include a reduction in CO2 emissions by 3,000 tonnes. This solar system would also reduce the amount of energy that Bega consumes by 30%. This proposed system is currently being simulated at Bega Cheese by a data logging device. This data logging device takes solar irradiation and temperature readings. These two measurements are important as they are used to calculate the amount of power that a solar panel can produce. The data that will be recorded from this device will be compared to the output of one solar panel that has recently been installed at Vegemite Whey. Both of these results will also be compared to the industry standard model and the MATLAB model. From all of this data, formal recommendations will be made to Bega Cheese to assess the validity of the MATLAB model, the industry standard model, and the overall feasibility of the solar project. Over the course of this video, we will hear from one of the executives of Bega Cheese about the history of the company and what it has become today. I will then explore solar technology and explain how it is used to generate electricity. I will then discuss the solar model, both the industry standard and the one that I have produced using MATLAB. And finally, I will finish the video by exploring the data logging device and the ongoing solar trial at Vegemite Whey.
Hi, I'm Brett Kelly. I'm the company secretary for Bega Cheese. I've been with the company since 1995, where I was originally employed as the chief accountant, reporting to the chief financial officer, so responsible for all the financial reporting, analysis, budgeting, tax, etc. My role has changed as the company has grown over the years, where I'm now the company secretary responsible for governance, risk and shareholder relations. So Bega Cheese has been around 120 years. We were a cooperative which was established in Bega in 1899 by the dairy suppliers who wanted a good avenue for the sale and manufacture of products from the milk that they supplied. As the company grew, we realised that for the farmers to realise the equity and wealth that they built up in the company, and to allow for future expansion of Bega Cheese, we needed to change from a cooperative into a publicly listed company. We did that in 2011. We were already on a growth phase, having started with the one factory at Lagoon Street in Bega, which manufactured bulk cheddar and whey powder. And at that time we used to get other companies to convert our cheese and powder into retail packs. We then built our own retail cutting facility also in Bega, but continued to expand, constructing and buying other companies in Victoria, including Tatura Milk Industries Limited, which is a wholly owned subsidiary which produces cream cheese and nutritional products, helping us expand our, if you like, our dairy footprint and dairy products that we're able to sell. As we've grown over the years, we wanted to have a sustainable business for our farmers to help them survive, particularly in the periods of drought, but also to make our company less susceptible to the rise and falls in economic, climatic conditions and commodity pricing. So as we've grown, we've made the strategic decision to, if you like, change from the Great Australian Cheese Company to the Great Australian Food Company. And a big step in doing that was the acquisition of the Vegemite factory in 2017. That has enabled us to have direct input into the retail space with Vegemite, peanut butter, salad dressings and similar products, and as I said, enables us to have a much more broader array of products available to sale into the market. We've also strengthened our dairy footprint, particularly given the changes in climatic conditions and the availability of milk due to climate change, by acquiring a huge factory in Koroit in Western Victoria, and since then have started to extend our food businesses by acquiring a company called 180 Nutrition, which is an e-commerce reseller of nutritional, sports and healthy products. So Bega Cheese, when I started in 95, had around 100 employees with turnover about 120 million, whereas today our turnover is around 1.4 billion, 2,000 employees and net assets in excess of $1 billion. Sustainability is very important to us, and if you look at our 2019 sustainability report, which we recently announced to the ASX and is available on our website, that Bega Cheese is very focused on reducing its carbon emissions and energy consumption, and we believe projects such as this are very important to our future sustainability.
Now that we've heard a bit about Bega Cheese, let us talk about solar technology. Solar energy is one of the most widely used forms of renewable energy. In Australia, solar makes up 22% of all electricity generated by renewable forms of energy. Solar energy focuses on using the power from the sun, solar irradiation, and converting it into electricity. This is done by small devices known as photovoltaic cells, which are made of crystallized silicon. These devices use the photoelectric effect to produce electricity. There are approximately 60 solar cells in one solar panel, and there are several solar panels in a solar system. Now that we understand solar technology, we can discuss the solar models that have been used in this presentation. The solar model that has been incorporated by MATLAB mostly focuses on the solar declination angle. This is the angle between the Sun and the equator of the Earth. This angle changes for every day of the year as the Earth rotates around the Sun. And the solar irradiation will consequently change every day because of the Earth spinning on its axis whilst rotating around the Sun. There are unfortunately a few deficiencies with solar systems. These deficiencies are temperatures over 25 degrees Celsius. Contrary to popular belief, hot weather is not good for solar panels. Another deficiency is the solar tilt. The solar tilt is the angle that the solar panel is positioned. If this angle is not perpendicular to the solar declination angle, we are not gaining the most efficient amount of solar irradiation possible. The final deficiency that is accounted for in this model is cloud cover. Cloud cover is by far the most problematic decrement to solar systems, and this is because they have the potential to reduce your power output to 15% of their rated value. These figures show you what the output looks like from the solar model on a purely sunny day. One is over one day of the year, and the other is over the whole course of the year. The industry standard model calculates the annual solar output by multiplying the rated power value, which for this system is 2,225 kilowatts, by 1,250. Hence, we get the 2.7 gigawatt hours per year. The model that I have produced in MATLAB uses the solar irradiation values we previously discussed and multiplies them by the area of the panel, the rated efficiency of the panel, and the total number of panels within the system. Now let's examine the data logging device that was designed for this project. The data logging device includes a light sensor and a temperature sensor, which are connected to a PSOC microcontroller. PSOC microcontrollers are designed by Cypress Semiconductors. The PSOC microcontroller calculates solar irradiation from the light temperature and gathers the temperature reading from the temperature sensor. These two values are then transferred to a Raspberry Pi every 6 minutes. The Raspberry Pi will also take a photo whenever it receives this data. This data can then be stored onto a USB stick or a USB hard drive and can then be examined at any other point in time. Preliminary testing of the data logging device has shown that the results are accurate to within 5% of what the MATLAB model predicts. This, however, is only in pure sunlight. The device needs to be further calibrated to account for days which are cloudy and are not purely sunny. Over the next several months, to compare the data that is logged by the device and that of the MATLAB and standard solar models, a solar trial is being conducted at Vegemite Way. This solar trial consists of one solar panel, which is connected to an arbitrary load, and the power that is generated is measured across this load. It is my hope that the power that we see generated from this panel matches that of the data that is logged from the device and that of the MATLAB model. Over the next few months, data will be taken from the data logging device and the solar panel currently installed at Vegemite Way. These will both be compared to the solar model and the feasibility of the project will be determined. It is my hope that if the project is proved to be feasible, the roof of Vegemite Way will soon be looking like this.